This video discusses modular systems. First, let's talk about the word modulus. This word is Latin for remainder or residue, okay? Or what is left after the parts of the whole are taken. So when we look at the word modular or mod arithmetic, it's really remainder arithmetic. Right? Well, more precisely, we're looking for the integer that occurs as a remainder or the leftover when one integer is divided by another. Okay, so what does that really mean? All right. Well, we all know how to add numbers, right? But did you ever think about how strangely it is when we add hours on a clock? If it's 3 o'clock and we add 5 hours to the time, that'll put us at 8 o'clock. So we could write 3 plus 5 is 8. But if it's 11 o'clock and we add 5 hours to the time, it's going to be 4 o'clock, right? So why can't we write 11 plus 5 is 4? Now, everyone knows that 11 plus 5 is really 16, but there's no 16 on the clock. Well, unless you're in the military, but we'll get to that in a minute. Every time we go past 12 on the clock, we start counting the hours at 1 again. If we add numbers the way we add hours on the clock, we say that we're doing clock arithmetic. So in clock arithmetic, 8 plus 6 is 2 because 6 hours after 8 o'clock is 2 o'clock. So how do time and modular arithmetic relate to each other? Well, modular arithmetic deals with repetitive cycles of numbers and remainders. The time you use every day is a cycle of 12 hours divided up into a cycle of 60 minutes. Okay, well, let's talk about the 12-hour cycle. Every time you pass 12, you start over with 1 again. This is called mod 12 arithmetic. And we can apply that mod 12 arithmetic to anything that has a cycle of 12. Think about 12 months in a year, right? So that's also going to be mod 12 because every 12 months it's going to cycle and start all over again, right? So January is 1, February is 2, all the way around, 11 is November, and then 12, or 0 in this case, is going to be December. And then again, we start all over again. January is number 1, February is number 2, etc. Okay, now I mentioned military time just a few minutes ago. Well, military time's on a 24-hour cycle. Well, that would be mod 24. And I put a little image here so you can kind of see what I'm talking about. If this were on the outside all the way around, it would be 1 through 23, and then at the top is going to be 0, which would indicate you're 24. This is just showing an actual clock so that you just kind of go around twice on this one to get to 24. But picture this as 0 through 23, and then that's mod 24 arithmetic. Okay, so now remember, every time you pass 12, you're going to start over again. Let's look at some mod 12 arithmetic, okay? So the answers to addition on the 12-hour clock can be found by counting clockwise around the face of the clock. So you're going to go to the right. So if it's 7 o'clock now, in 8 hours, it's going to be 3 o'clock, right? So what you would do then is 7 plus 8 is 15, right, in regular arithmetic. Well, since we're on a 12-hour cycle, we're going to take that 15, divide by 12, and take the remainder. The remainder is the actual time that it's going to be. So in this case, 15 divided by 12, right, it goes into it 1 with a remainder of 3, okay? So that 3 is what we're looking for. So it's 3 is our answer in mod 12. Okay, so let's look at mod 12 subtraction. Subtraction means add the negative of the number in a counterclockwise direction. So now we're going to go to the left. All right, so using our same numbers, okay, if it's 7 o'clock now, what time was it 8 hours ago? Okay, well, if we look here, we're going to take 7 and then we're going to add the negative because we're going to be going counterclockwise, okay? So 7 plus minus 8 is minus 1. And so because we're going counterclockwise, we're going to now add the mod that we're in, and we're in mod 12, so we're going to add 12. Well, that brings us to 11, okay? So that's our answer. It's going to be 11 o'clock in mod 12. Okay, let's do another subtraction. Subtraction usually gives students a lot of trouble, so I like to have extra examples for subtraction. Okay, again, subtraction means you're going to add the negative of the number in a counterclockwise direction. Okay, so again, we're going left. All right, so we're starting at 7 o'clock. What time was it 5 hours ago? Okay, so we're going backwards. Okay, well, 7 plus minus 5 is going to be 2. So that tells you right there that it's going to be 2 o'clock in mod 12. All right, let's look at another example. If it's 2 o'clock in New York, what time is it in LA? Well, California is 3 hours behind New York, right? So if it's 2 o'clock, we're going to add minus 3. That puts us at minus 1. And because we're in mod 12, we're going to add 12 to get us to 11. All right, so it's going to be 11 o'clock in LA. All right. All right, so let's look at another one. If it's 3 o'clock, what time was it 50 hours ago? All right. So, I mean, you could sit there and, start at 3 o'clock and then go backwards 50 times, right? 50 cycles, but that is a little bit time consuming. So let's do the math. All right, so 3 plus minus 50 puts us at minus 47, okay? Well, at this point, we're in the negative. So we need to keep adding our cycles of 12, okay, to until we're out of the negative, and then that number that we're left with is between 0 and our modulus, and our modulus in this case is 12. Okay, so all right, so we have 3, we're going to add a negative 50, that puts us at minus 47. Well, we're still in the negative, we got to keep adding 12. All right, so add another cycle, so we add 12 more, that still puts us in the negative, we're at negative 35. All right, so we're going to add 12 again, puts us at negative 23. We're going to add 12 again, that puts us at negative 11, and then we're going to add 12 again, and that puts us at 1. Now we're positive, it's between 0 and the modulus, so we're going to stop. Okay, so if it's 3 o'clock now, that means it's 1 o'clock 50 hours ago. Okay, you see how that works? So that is mod subtraction. All right, one more subtraction, but let's switch it up a little bit. What about 11 minus 50, okay, or you could say 11 plus minus 50, it's the same thing, okay, but what is that in mod 15, okay? Well, it's the same process, except our mod now is 15. So we're going to take 11, we're going to subtract 50, that puts us in the negative, so we're going to add another cycle, and in this case, our cycle is 15. Okay, so minus 39 plus 15 puts us at minus 24. We're still in the negative. We got to keep adding another cycle. So we add another 15. That puts us at minus 9. We're still in the negative. Add another 15. Oh, that puts us in the positive. So 6 is our answer in mod 15. So 11 minus 50 in mod 15 is 6. All right. Well, based on what we just did, let's look at what those rules are. We're going to write what we did down as a protocol. Okay, we've got a couple of rules here. All right, rule 1. Any number A can be changed to a number B in a specific modular system M by dividing A by M and then taking the remainder of B. Okay, so you're going to see this written as A, and then you're going to see 3 horizontal lines and then B. All right, so those 3 horizontal lines mean congruent. Okay, and all congruent means is same as. So anytime you see the word congruent, just replace it with same as. Okay, so this is written as A is congruent to B in mod M. All right, or in modulus M. All right, well, let's look at our second rule. The operations of addition and multiplication in modular systems, they can also be performed by adding or multiplying the numbers as you normally would in regular addition or multiplication, and then converting that answer to the equivalent numbers in the specified system using rule 1. So what we're going to do is we just do add or multiply just like we would, all right, in a normal system, and then apply our rule number 1 to that. Okay, so let's look at some examples. All right. What if we have 5 times 6 in mod 9? All right, so the rules say multiply as usual. So if we multiply 5 times 6, we get 30. Now we're going to take that answer and we're going to apply it to our rule 1, which says to just divide by the modulus and then take the remainder. All right, so 30 divided by 9, because 9 is our modulus, gives us 3 with a remainder of 3. So our modulus, because we have to take the remainder, so our answer in mod 9 is going to be 3. Let's do a real-world modular arithmetic. All right. Suppose that your aging father needs to take 1 antibiotic pill 3 times a day for 10 days. Okay, well, that's 30 pills, right? 3 pills times 10. is 30. Well, every evening you check in to make sure that the pills were taken. When you ask your dad if he took his second pill, you receive that blank stare. All right. Well, as you can see, many real-world applications exist for modular arithmetic. All right, we can use this for our failing memories or to help assist in our home care, right? Well, modular arithmetic in this case can be used to check to see if those pills were taken. So the first thing that we need to do is to count the remaining pills, okay, and then convert this to mod 3. So let's just say that he had 26 pills left in his pill bottle, all right? Well, what we need to do then is, because we're using mod 3, we're going to take 26, our remaining pills, divide it by 3. All right, that's going to get us to 8, right? Because 8 times 3 is 24, and that's going to leave a remainder of 2. So in this case, our answer is 2 mod 3, right? In mod 3. All right, so, well, what does that mean for our real world problem here, right? Well, if the answer is 1, that means he took his pill, right? That other pill remaining is going to be his evening dose, okay? The answer is 2, which in our case, because he had 26 left, the answer is 2, right? Well, that means he missed his second pill, all right? If the answer were 0, that means he missed 2 doses, okay? So this is how modular arithmetic can help us solve real-world problems. So in this case, what do you think the number is that is congruent to 26 in mod 3? Well, 2. As you've learned in this lesson, modular arithmetic is useful for so many real-world applications. So it's important that you at least get a little bit of an understanding of how modular arithmetic works. It can help you even in your home. And that concludes this video.